Good day, students. Welcome to Microsoft Academy. So as you guys have requested for some revision questions, we are going to be looking at some exam questions on physics 114, 118, and 124. Now, this is under Kirchoff circuit. This is one of the questions you are going to see on Kirchoff circuit. So we quickly analyze these circuits. They say we should find the currents I1, I2, and I3. So the circuit is given. Now we can see that I1 is here, our I3 is located here, and our I3 is located here. So from our Kirchoff's laws, we have two laws. The first one talks about the junction law, and the second one talks about the potential law. So in the first law, it says that the sum of the currents entering the junction is equal to the sum of the current leaving the junction. So this is under the conservation of charges. So now, if we look at this current, I1 is entering this junction. We can also see that I3 is also what? Entering the junction. But I2 is leaving the junction. So in that case, one can say that I1 plus I3, which is entering the junction, is equal to what? I2, which is leaving the junction. Now I will call this equation 1. So because we are able to get a relationship between I1, I2, and what? I3. Now we need to go to get the other relation that can help us to get the values of this I1, I2, and what? I3. That is where the second law of Kirchoff comes in. Now, what does the second law say? It says that the sum of the potential drop in a circuit is equal to the sum of the word EMF. So that means that the sum of the EMF equals to the sum of the word potential drop. So which, if we bring this potential drop over to this place, we'll be having that EMF minus the potential drop will be equal to what? 0. So this will help us a lot in analyzing this circuit. So we have our EMF minus the potential drop equal to 0. So you see that when we deal with potential drop, we'll be using a what? A negative. Very, very important. Now, let us look at the circuit. We have two loops here. This is the first loop, and this is the what? Second loop. So I will call this loop A, and I will call this what? Loop B. Now, from our loop A, let us analyze loop A only and see what it has for us. Now, we are going to assign a direction to our loop A. Assigning the direction, I can decide to choose this direction, I can decide to choose this direction. So any direction you want to choose, there's no problem. So if we choose a direction like this, it means we are moving this way, which is an anti-clockwise movement. So if we move like this, you are going to see we'll be moving through this loop A, this direction. Now, if we start from any direction of our choice, let's start from this point here. Now, you see that these are terminals. We have the negative and the positive. So from the negative, the last one we get is the what? Is the positive. So that means we are dealing with positive of what? Of 8 through that direction. So we have positive of 8. Now, if we keep on moving through this loop, we are going to see that there will be a potential drop between the resistor and the what? And the current. Now, take note, the potential drop V is equal to what? IR. That is from your Ohm's law. V equal to what? IR. So we multiply I and the resistance, we are going to get the potential drop. So let's go. We multiply 10 times I1, we give us what? 10 I1. Remember, when we deal with potential drop, we are going to be looking at a minus because of the word potential drop. Now, if we keep on moving that direction, we meet a positive and then we meet a what? A negative. That will give us a what? A minus what? 6. Now, if you keep on moving that way, you see we'll get back to this position we have gotten before. But this I3 will be useless because there is no what? Resistor to cause a potential drop. So that means we have just this equal to what? 0. Why do we equal to 0? From this law, it says the EMF minus the potential drop equals to what? 0. So that is how we call this. Now, I can find my I1 from here. If we make I1 the subject formula, we first of all look at 8 minus 6 will give us 2. So if we have 2, we can move 2 over to this place, it becomes minus 2. So what I'll be having will be minus 10i. So this one is already 2, so plus 2 equal to 0. If we move our minus 10i to this place, we'll be having 10i 1, then we have equal to what? 2. So divide through by 10, divide through by what? By 10. This will cancel. Here will cancel 1, here will cancel, give us what? 5. So we have the answer as 1 over what? 5 what? Ampere. That is my what? My I1. So we have gotten I1 as 1 over 5 what? Ampere. So that's the first current I1. Now let's get the second current. Now let's choose a direction for loop B. Now we are working on the loop B. So for loop B, we can see that we can choose any direction of our choice. I can decide to maybe choose this direction. So this is how I am moving for loop B. So we move, remember everything here is our loop B. So if you keep on moving this way, now let's start from here. You can start from any point of your choice. Since you are following this direction, keep on following the direction. So we have a negative, the smaller one shows a negative terminal and the longer one shows a positive terminal. So we have here that this is a negative to a positive from our direction, meaning that our 12 will be what? Positive. Now if we keep on moving that way, we are going to see a resistor and a what? A current, which means that there will be a potential what? Drop. So we have 16 will be multiplying with I2. Remember, we put a what? A minus. Then we have 16 what? I2. Now we keep on moving that way, we get to a positive and then to a what? A negative. So we have a negative of what? Of 8. So this is negative of 8 for the EMF. Now this is the current I3 and there is no resistor to cause a potential what? Drop. So we don't take it because I3 times 0 will give us what? 0. So there is no potential drop here. We come back to this place, we have already solved this, so no need to repeat it. Then remember everything equal to what? To 0. Now we have 12 minus 8 will give us 4. So we'll be having 4 minus 16 I2 equal to 0. So if I move this over to this place, we'll be having 16 I2 is equal to plus 4, because this has crossed over to this place. So that means we'll be working on I2, we divide by 16, we divide by 16. Here we have that I2, this will cancel out 1, here will be what? 4. So we're having 1 over what? Over 4. So that means our I2 is 1 over what? Over 4. So we have gotten our I2. Remember the question says get for I1, I2 and what? I3. So we have succeeded getting I1 and we have gotten what? I2. Now how do we get our I3? Now if you watch it from here, you will have from our first equation, equation 1, when we look at the Kirchoff's first law, we saw that this is what is happening, that the sum of currents entering the junction equals to the sum of currents leaving the junction. So here we have gotten our I1 from the first loop and we have gotten our I2 from the second loop. So that means that we can calculate our I3. So quickly what you do, make I3 the subject formula, make your right substitutions, and then you calculate for I3. So that means we'll be having our I3, making I3 the subject formula, we are going to move I1 over to this place. So if I1 crosses, it becomes minus what? I1. Now we can go through the circuits and make the substitutions so that we have I3 for our loop 1, we got that I1 is equal to 1 over 5 as our I1. Then we also have I2 to be equal to 1 over 4 from our loop B. Then remember the formula here says minus. We have a plus, we have to put plus. So what we calculated was a minus. So we subtract this, we look for the LCM. LCM is 20. You go through, you have 5. When you divide and multiply, use 20 to divide with 5, you have 4. Multiply with 1, you have minus what? 4. Now we can do this. This will give us minus. This will be 1 all over what? 20 ampere. So that gives us our I3. So in a nutshell, we are saying that our I1 is equal to 1 over 5 ampere, our I2 is equal to 1 over 4 ampere, and I3 is equal to 1 over 20 watts ampere. So this is how you solve the Kirchoff's circuit using this different way of analyzing first law and the second law of what? Of Kirchoff. So we are going to still make more videos on different aspects of electromagnetism for your revision classes. So you are going to be watching them to learn them and see how they ask questions in exam. So if you are new to the channel, do well to subscribe, click the subscription button, go to the comment section, any question you have, send your questions there. My sort will be ready to solve them and explain to you. Thank you.